usually I say use wheels, don't reinvent them, but I'm going to reinvent the wheel so you can see how functional interfaces work and how they are a quick and efficient way to get a wide array of things done. So to this end, I'm going to go and create an interface called RealFunction. And I'm going to give this interface one method, call. Now this is meant to model a mathematical function. So RealFunction is going to model a function, a real function of a real variable that you might see in a calculus class. So now we've created RealFunction. So how can we use such a thing in an interesting way? That is what we're going to do next. Now, before I come out of here, I'm going to do this. I'm going to put an annotation here that says functional interface. A functional interface is an interface that specifies exactly one method. And so this is specifying the method call and nothing else. Now I'm going to open a new class called Table of Values Generator. Okay, Table of Values Generator. So public class Table of Values Generator. And you might think I'm going to implement RealFunction. No, I'm not going to do that. Okay, so inside of here, I'm going to do something that's a little unusual. I'm going to declare a RealFunction type variable. So this is a variable of interface type, and you can use variables of interface type for state in a class. So my constructor is going to look like this. Let's see, I'm also going to say this. Okay, so here I'm going to make an array list of values of double type. Okay, so there's my state variables, and I'm going to make them private. Come on. Oh, it's getting into visual mode. Okay. Okay, and I'm going to say private. And I should go ahead and enter that as well. So these are my two pieces of state. Okay, and table of values generator is going to take a RealFunction f, and it's going to take an array list of doubles. You'll notice I'm using the wrapper type here as a standard practice. Values. All right, and so I'm going to say this dot f is f, this dot values equals values. Okay, and now I'm going to close this off. And I think I'm going to shrink this window just a little bit, if you don't mind, to keep everything on its own line so it doesn't look wild. Okay, I think I've typed enough code. I'm going to compile. I'm going to go ahead and javac RealFunction. Okay, and I'm going to javac table of values generator. Okay, I forgot a semicolon. Oh snap. Let's get that. Okay. It always pays to compile as you go along. Then you clean up cruft like that. Oh, I must have misspelled my name of my class, table of values generator. Yes, you can see that, incidentally, is a very typical error if you misspell your constructor or your class name. Useful to see that. Okay, so now this is going to go ahead and generate it's going to compile. Whoops. Oh, again. This is not tennis. There we go. It's really easy to do that. So what's going to happen is that this is going to generate an HTML table of values as a string, and it's going to allow you to pass in a function as an argument. That's the cool part that's going on here. All right, so we've got that. So let's think about this. I'm going to make a string class here. I'm going to write a function to generate each line in the table, and then I'll write a function to generate the entire table. So these are really two sort of discrete tasks. So we may as well do them separately. So what do I need to do here? Okay, so let's go ahead and make row. What do I need? I need a RealFunction. Okay, oh, I have my RealFunction f. So I don't have to do that, but I do need a value. Okay, I need a value to do this. All right, so now I'm going to make the row, and I'm going to use string.format. Okay, so I'm going to say string.format. I'm going to return this. Begin table row, begin table datum, placeholder, end table datum, begin table datum, %s. Okay. So what goes in here? Well, my value goes first, and then f.call a value. Okay, f.call a value, and it's guaranteed that since our RealFunction is implementing, since we're implementing RealFunction here, call makes sense. So we now have something that returns that. All right, so I'm going to go ahead and compile again. And this is a slightly slow. Oh, wait a minute. I forgot to specify the type that goes in here. Occasionally, I am known to Python. Okay. And I just Pythoned. Okay. So we wrote our function. So far, nothing super duper special seems to have occurred. Now what I'm going to do is I'm going to build the table. And you know what I'm going to do here is I'm going to go ahead and put a whack n at the end of each of these lines. So my string looks decent. All right. So now I'm going to do this. Make table. Okay, what do I need? I don't need anything, because as state, I have a real function and I have values. So let's go ahead and make the table. All right, so I'm going to say string out is equal to table whack n. Then I'm going to put this in tr th, and I'll put an x here. You can put whatever letter you want, but this is sort of math oriented. And I'll just say f of x here. I'm just going to put literal things in here. All right. All right. So there's my table. There's its head. And while I'm at it, let's put the close tag in so we don't forget it. Okay. Now we're ready to take care of the middle. So what I'm going to do here is I'm going to say for double let's see, I'll say x in values. So for each value, we are going to say out plus equals make row of x. And you can see that building this extra function makes our code much more readable because it's very easy to follow what's happening here. I'm putting in the header of the table. Now I'm putting in all the rows, and now I'm closing the table. And now I've made it. Okay, this is my table of values generator so far. It looks pretty good, but let's go ahead and javac it again to make sure that it's copacetic. Then I'll show you how to use this. Oh, semicolon expected. Yeah, let me patrol for those. Oh, come on. Ooh, what happened here? Oh, I see another window just crept in front. All right, so there's a semicolon missing there, and there's one missing there, and there's one missing there. All that visual clutter. Yeah, you're going to get that sometimes. Beep, beep, boop, boop, boop. Okay, here it comes. What? Missing return statement. Oh, I forgot to return out. Well, it's better than that it's better than that trip to the convent you get from Python. It just returns none. Yes. Okay. So we're going through all the little steps here. You're seeing me generate this thing live, and that's why you have to put up with the compiler errors, but you get to see what I do. All right, so now I've created this code. So what's the big deal? Well, let's give this a main and take it for a spin. Okay, we'll take this for a spin. So here's what I'm going to do. I have a table of values generator. All right. So let's go ahead and do this. I need a RealFunction object. But what I'm about to do is going to have a heretical appearance. I'm going to specify a lambda. All right. And now let's put some values in here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's just chuck in some numbers here. Okay. And now I'm going to say tg dot make table. Okay, and I don't have to pass it any values. Okay, so I made a table of values generator. Here I've specified its state. Its state is the cubing function. Ooh, what did he do here? And then here's a list of values. Well, first of all, you got to be justifiably skeptical. Let's see if this thing actually compiles or if we're all being taken for a big fat ride here. So I'm going ahead and compiling. Maybe I'll get a semicolon error. Ooh, whoops. Ooh, what happened here? Oh. You know what I need to do? I'm doing a Python thing. Yeah, I need to make my list. I can't do this way. Okay, I have to do this way. Let's call that Y, for lack of a better name. Hey, this is like math class. Is equal to new array list. All right. Double, and I don't need to do that. I can just use this diamond operator here. All right. K equals 0. K less than or equal to 10. I'll make it even snazzier. K plus plus. Okay, so now I'm going to say Y to add of K. I'm taking advantage of how the wrapper classes work. And now I'm going to pass in Y. Yeah, because that's something I'm definitely not allowed to do. I started Pythoning there, and that got me in trouble. That was a pretty radical error message. Okay, I just need a semicolon. Oh, yes, after all that hoorah. The semicolon was missing. Okay, so come on. Uh-oh. Array list.add. Int cannot be converted to double. Oh, good grief. That's really annoying. Okay, this is like the height of annoyance. An integer should be accepted by a double, but we're encountering some serious hair splittery here, so let's go ahead and do that. It cannot be converted to. Yes, because we are auto boxing and auto unboxing, and that's why. Beautiful. Let's run it. Hey. Make sure my main is correct. Yeah, here's my main. Okay, let's compile that again. Okay. O.java. File not found. Wait a minute. Oh, table of values. How irritating. All right. That's the problem. Table of values, not table of value. And then when I run it, I'm going to get exactly what I have coming. And then I have something to explain because something complicated has gone on. Ooh, did I not print it out? Oh, let's see. Oh, yes, I did not print it out. Okay, let's make sure we got the right number of parentheses here before we bail out. Oh yes, very good. Okay, virtual machine on this server is really slow. Boom! There we go. We got something that generates a table of values. Now let's go in and look at this and see what happened here. What happened here? We made a function-like object. Okay, this lambda, what happens with this lambda? I can pass this lambda into RealFunction. All right, now why can I make a RealFunction like that? Because of this reason. RealFunction is a functional interface. It specifies one method, call. And what Java says when I do this down here, it says call. This is an object. This is an object from a class that implements RealFunction, and its call method is exactly this. Here, let's do another little stunt here just for fun. I'm going to say RealFunction G is equal to, and I'm just going to write a lambda over here. X to the fourth plus x squared plus 5. There's my RealFunction G. Now I'm going to say, I'm just going to yank this because it's so annoying to type. All right. And you know what? I'll just say TG is equal to, and I'm just going to put my G in here. And G is an honest-to-God object. It's an object that is an instance of a class with no name. But it implements RealFunction, and its call method is specified right here. Okay, let's see if this full thing works. Okay. Yeah, the names are long, and that makes us vulnerable to mistyping. It's kind of annoying, but this is the life of the Java programmer. Okay, so now we're going to go ahead and go Java. Okay, oh, I didn't print it out. I do need to print that out. Oh, I need to say, oh, I needed to yank the other line here, which I did not do. There we go. We made the table. It's in memory, but we just didn't print it. Now we'll print it. So we'll get both tables. And you can direct these into a file. You can suck them into an HTML document. System.format, incidentally, has a means of controlling how many places you go beyond the decimal point. And you could even fancy this class up by having a default value, say 4, but allowing the user to specify a different value. So now I've Java C that. Let's Java it. This is kind of fun. Okay, so there it is. Here we are. We're x to the fourth plus x plus 5. And you can see that 3 to the fourth is 81. 3 squared is 9. So 81 plus 9 is 90. Then add 5 to you get 95. So here's your tables. Here are your tables of values that you've generated. The moral of this story here is that we can make function-like objects using functional interfaces. And this is only one application of this kind of chicanery in Java. So this gives Java a more functional kind of more functional techniques are available, and you're going to see things of this nature occurring a great deal later on in these chapters. So this is functional interfaces from scratch. Now I will tell you that the standard library has a package, java.util.function, and I will take you on a very brief tour here and show you where it is, and maybe you should do some spelunking on your own. Let me get my browser out, my happy browser, and I'm going to type in the search window here, java.util.function. And I'm missing an I in util, even though the type is really tiny. Here it comes. Hey, didn't do that. Come on, java.util. There it is, .function. I think it was capitalizing function. Yes, java.util.function. Everything in here, and I mean everything, is a functional interface. Okay, now maybe you've seen this before. There's something called a consumer. A consumer is a functional interface, and it's parameterized. So a consumer of strings is a function that takes a string and has a void return type. Okay, has a void return type. So there are a whole panoply of these things. Now, let's see if I can find my RealFunction. Let's see. You know, mine is really a unary operator, which seems kind of odd, but it's true. What I really did was recreate unary operator with a double as its parameter. Okay, this is a functional interface, and it basically takes it's a function that maps as domain a type and as range a type, and the two types have to be the same. So in this case, in my case, T was double. So I was really recreating this class. Okay. Now, here's another thing you're going to see that's kind of NC-17 rated, and I may as well tell you boys and girls about it now. There are these methods that are out there. Now, this is the only method you are required that is specified. The other methods are marked default. Okay? Default methods are a Java 8 mechanism that allow developers to give default implementations to methods rather than specifying them. It's almost like it's halfway between, you'll see something later called an abstract class. It's sort of like impinging on the notion of abstract class. But this is marked a functional interface because this is the only method that is specified that you are required to implement. You are not required to implement these. They are default methods. And so if you assign a lambda to something of this type, to a unary operator, what's going to happen is that lambda will be inferred to be the apply method. Okay, so now you know about default methods. They are out there. They're kind of a funky thing, but what's interesting is they don't ruin the functional interface. Now, one other dangerous bend I should talk about before I conclude is this one. And this is a trap that people sometimes fall into. I'm going to make a functional interface. Let's call this Parent. Okay. Okay. Public interface parent. All right. And I'm going to say hey, let's say dote. Why not? All right, doting parent here. All right, public string dote. All right, that's the method that I'm going to require here. And I'm going to come up here and mark this at functional interface. Okay, so now I'm going to go ahead and I'm going to compile that. And Java should be perfectly happy with it. Right? Perfectly happy. That compiles. Now I'm going to make child.java. Interface. Child extends parent. What did children do? They lobby. All right. Okay. I'm going to mark this functional interface. Now I'm going to compile it. And whoops. The child interface is not a functional interface. Why? Because the child interface, if you are going to implement the child interface, you will have to implement parent's method dote and child's method lobby. So watch out for that. Functional interfaces can only specify one method. And when methods are specified, that includes methods that are specified by any ancestor of that interface. Okay, so that's a dangerous bend. I wanted to make you aware of it. And now you know about function-like objects, and you know about them from scratch. In the next video, what I'm going to do is look at some of the standard library interfaces, and we'll play around with those a little bit.